Airspeeder has successfully launched the world's first electric flying car, and everyone seems to be staggered. The world of technology seems to have propelled itself in a new direction, where we'll actually be seeing flying cars for the first time. Although there was some hype about this back in 2020 when Airspeeder announced its plans, the hype is really incomparable now that it is a reality. If a flying car itself wasn't amazing enough, the fact that it is electric makes things go much better. Needless to say, that easily removes most barriers this new technology could have faced in the name of environmental concerns. Without further ado, let's get to know this magnificent piece of technology and how that could open an entirely new industry of flying race cars. Although Airspeeder has introduced the concept of flying race cars, the prospect of airborne vehicles to date has been limited to air drone facilities and other conventional methods of flying. Hence, the idea of everyday air travel puts forward the varying and numerous hurdles of such a futuristic prospect. Air trafficking has hence been on the forethought of many experts, as it proposes the multitude of halting points in this sector of industry. Low, high and regular airspaces and the intersection in between would potentially require a body of regulatory aviation authorities to maneuver and measure such murky and unknown waters. For example, the FAA and the European Aviation Safety Agency. Furthermore, the finance and effort required to set this industry on its course demand every type of certification and approval from regulatory authorities, as well as assurance from testing facilities to verify and okay the prospect and eventually the use of airborne vehicles. Consequently, many experts hence place the prospect of flying cars to be ready and put to practical usage by the year 2028. However, many flying companies such as Archer, Joby, Lilium and Airspeeder have not only initiated but are well on the course of competing with one another in this field of air travel and racing. Consequently, due to the varying complexities around development and legality, the concept of air taxis is gaining more and more fame and recognition. German-based company Volocopter desires its own VoloCity to be the first commercially licensed electrically powered air taxi. Although, in trials, it has flown with a pilot at the controls. The end goal, however, is to eventually enable autonomous flights with only passengers involved. Similarly, many other companies are looking to develop and provide market-ready projects as early as possible. Hence, airborne vehicles also include petrol-based vehicles with carbon emissions and electric-based projects with the advent of a new type of battery enabling personal air travel and a prospect of a cleaner and sustainable method, whereby an environmentally friendly means of transport. In addition, different companies are looking to develop their own style of airborne vehicles to meet their desired ends. Hence, one can already spot varying models of alternative types of such cars, such as drone-style vertical takeoff multicopters, as well as others with folded wings that require their very own runway. The PALV Liberty gyroplane flying car is moving closer to airworthiness certification by the EASA, which has recently agreed on the process. Its Dutch makers need to follow to gain type approval. The vehicle is already licensed to run on roads like any other car. Similarly, Terrafugia's Transition, a flying car with folding wings, has been granted a special light sport aircraft or LSA airworthiness certificate in the United States. It's not yet approved as a car, but the makers say their goal is to be legal both in the sky and on local roads by 2022. Others are close behind, with the Aeromobile luxury flying car aiming to launch in 2023 with a top speed of 160 km an hour and a flying range of 740 km. On the road and in the air, prices are reported to start from 1.6 million. Consequently, Alauda, the Australian company proposing the Airspeed series, had first launched its project, the Mark I, in the year 2017. Similarly, the Mark II was also flown, tested and authorised as a successful 3/4 scale quadcopter in test flight at the Goodwood Festival of Speed last year in July. The Mark III advanced development prototype will be tested in the Mojave Desert by a team of test pilots recruited from the US Air Force and Martin Aviation. The Mark IV is being developed in the UK as well as in South Australia and will be later tested this year. Some 50 years ago, we could not have imagined cars crossing the 100 km an hour barrier in less than 5 seconds. Back then, if you mentioned to somebody about flying cars whizzing past that speed barrier in much less than 5 seconds, you probably would have been mocked for life. Now it's all different. Today is the future everyone imagined 50 years ago. According to the Airspeeder, its flying racing model, the Mark III, has successfully been tested and driven in southern Australia. The Mark III may be peculiar to look at, but it actually draws its inspiration from racing cars of the 50s and 60s. Some may call the design old-fashioned, but the performance outweighs any sort of criticism. The Mark III and the new Mark IV is an electrical vertical takeoff multicopter, or VTOL, which was tested remotely under the supervision of Australia's Civil Aviation Authority. What makes the Mark III unique is that it's actually a purpose-built racing car apart from being a flying car. Matthew Pearson, founder of Airspeeder and Alauda Aeronautics, is the man behind the ingenious idea of forming such vehicular transport and is looking forward to the widely anticipated aerial Grand Prix. The plan was simple: construct the ultimate high-performance eVTOL vehicle. The end result will be the Formula One of the skies, defining the future of motorsport and mobility. The Airspeeder has released information about their latest electric vehicle on their official website, the Mark IV, which you must have guessed is an upgrade to the Mark III. The Mark IV super flying car can hit a maximum speed of 160 km per hour. The unmanned Mark IV actually beats the internationally famed records of the Lamborghini Huracan and the Tesla Model S, clocking in at 3 and 2.5 seconds for the 0 to 100 km an hour barrier, respectively. However, you would be surprised to know that this record-breaking acceleration is not its most spectacular feature. Easily, the unique feature is the fact that the Mark IV actually accelerates from 0 to 100 km an hour in 2.3 seconds in mid-air. In its race mode, the air car can float in the 10 to 60 meter range. Felix Pierron, the head of design, uses cutting-edge CAD and three-dimensional modeling technology to bring his vision to life. His design combines the classic forms of the first Formula One vehicle from the 50s with a futuristic style that foreshadows a new era of mobility. This uniquely designed future car produces a powerful 520 horsepower or 400 kilowatts. Another brilliant feature of the Mark IV is the weightless drive. Clocking in at a mere 400 kilograms, the Mark IV uses the latest carbon fiber composite technology to ensure maneuverability, speed, and safety. As the founder of the company said, "This is a landmark moment in the dawn of a new mobility revolution. Competition drives progress, and our racing series is hastening the arrival of technology that'll transform clean air passenger transport, logistics, and even advanced air mobility for medical applications." The Airspeeder Racing Series promises that Alauda's racing octocopters will provide noisy and entertaining close proximity racing, and that the competition will help accelerate the development of eVTOL aircraft. Such events were unimaginable in the past and were only video game concepts. Now there is also the much important question of security. Without proper security features, flying cars in mid-air would be a traffic warden's nightmare. That's why the electric Mark IV introduces a ton of futuristic features. The eVTOL sector will benefit from a full range of safety features established in the crucible of sporting competition. Virtual force fields are created around the vehicle using the latest LiDAR and radar technology, allowing for close but safe and competitive racing. And in the case of a rotor failure, the octocopter configuration assures stability. That's all for today, folks. Hope you guys liked this video. Let us know what you liked about this car in the comments section below, and don't forget to subscribe to our channel. Also, hit the bell icon to receive instant notifications about our future videos. See you next time!